November of 2022. That's when ChatGPT came out. And by December of 2022, the world had grappled with, and certainly the tech industry had grappled with, what widespread adoption of AI was going to mean when we stocked our data centers full of GPU chips and rack densities started to go ever higher. What was that going to do to load growth? And truly within about a month's time, load growth projections started to get updated.
Although the big picture items are going to take a couple of years to work out, right? Anytime we want to make changes to the US power grid, it's going to take some time to do that. But if you don't start today, you're not going to actually be able to do it. So for SHI, as we look at, helping customers navigate through these challenges, the real answer is if you're not thinking about it today, if you're not planning for 3 to 5 years from now, you're going to miss it.
In the world of technology, heroes are everywhere. They're overcoming disruption, delivering sustainable outcomes, and fearlessly forging the future to solve what's next. Join me, Ed McNamara, as we meet the people and businesses driving change in our constantly disruptive world. This is Innovation Heroes, a podcast brought to you by SHI. When most people think about AI, the first thing they think about is chatbots and copilots. They think about automation, job displacement, maybe a robot apocalypse if they've seen too many movies. What they don't think about is electricity, but maybe they should, because the simple reality is AI runs on power, and it runs hot. The numbers are staggering. Data centers that hummed along on 20 kilowatt racks are now staring down 200 kilowatt monsters with megawatt-per-rack systems on the horizon. Transformers are backordered until 2027, turbines the 2030s. And hyperscalers are so desperate for clean energy that they're restarting nuclear plants and signing deals for reactors that don't exist yet. Today, we're exploring two technologies racing to solve the AI power crisis, one that's coming and one that's already here. First, we'll talk to Brian Smith, 20-year nuclear veteran now at Idaho National Laboratory, where he's helping build factory-sized reactors designed to be delivered on trucks. Then we'll hear from Ryan Hotchkin, Senior Director of SHI's Advanced Solutions Group, who's helping enterprises survive the global crisis happening right now. The power constraints, the cooling failures, the procurement nightmares that hit before the deadlines do. Let's talk about the future of nuclear power.
Thank you so much, Ed. Thrilled to be here with you.
I think most people hear nuclear power and think, massive cooling towers and decades-long construction projects. Right now you're working on something that's completely different. Can you walk us through what small modular reactors actually are?
For a sense of power output, scale, think of small modular reactors, or SMRs, as in the, I'll say 350 megawatt electric range and below. And the modularity piece, that means that they are largely factory built and assembled. Perhaps a microreactor is fully factory built and assembled. Maybe a larger SMR is mostly assembled in the factory and then final assembly occurs on site. But you can see the common theme with small modular reactors. This is something that it's almost like building airplanes, not airports. Rolling something off of a factory assembly line, then sending it out to its deployment location.
Can you help our IT leaders understand the connection, why AI is suddenly making a market for nuclear power and making it relevant again?
If we just go back a short period in history, November of 2022, right? That's when ChatGPT came out. And by December of 2022, truly, within about a month's time, the world had grappled with, and certainly the tech industry had grappled with, what widespread adoption of AI was going to mean when we stocked our data centers full of GPU chips and rack densities started to go ever higher. What was that going to do to load growth? And truly within about a month's time, load growth projections started to get updated. And within 6 months of that, indeed, we started to see the forecasts among regional utilities predicting, that traditional hockey stick that we talk about, just massive load growth. So, when I saw that happening a mere, handful of years ago. I said, okay, if I'm concerned about the traditional stalemate with utilities and I'm going to continue to kind of beat my head against that wall that has traditionally kept me from deploying nuclear in innovative ways, let me embed myself into the AI industry. Let me go to their conferences. Let me,
Mm.
engage directly with that industry so that I can try to forge partnerships between advanced nuclear vendors that are doing all kinds of really great things, many cases in partnership with Idaho National Lab out in Southeast Idaho, and let me get the AI industry engaged with them so that they can start having conversations about what the right kinds of deployment models look like for what I see is going to be massive, massive energy demand. That's what I've worked on for the last couple of years. And I think you've seen, certainly in 2024, a number of hyperscalers came out with agreements with various reactor vendors. Google and Kairos signed a partnership agreement whereby Kairos will start deploying their reactors for Google purposes in 2030, with a total of 500 megawatts planned by 2035. That was foundational, and that wasn't a deal between Kairos and a utility, right?
Mhm.
That's Kairos and a hyperscaler. The hyperscalers have money to spend, massive energy needs, and they, as first movers, they have a risk profile that perhaps is a little bit different from the utilities, and they're willing to write a check to get that highly resilient baseload power from advanced nuclear vendors.
In terms of, you've got companies like Oklo building, actual reactors at Idaho National Lab right now. What does the kind of public-private partnership look like, and how is the federal government, helping to accelerate this technology?
What the national labs have done very, very well over the decades is partnered with private industry to help move new technologies across the valley of death. If you think about the very important role that universities serve in cutting-edge research and development, ideas that maybe one day could germinate into something that would be able to be commercialized, but it's still a seed in the laboratory system. We, the laboratories, can run with those. Sometimes we've got seeds of our own, lots of great partnerships with universities to help germinate those seeds. But then we've got a lot of unique capabilities, say, for example, at INL when it comes to nuclear, to help bridge that valley of death and prove out through the, say the technology readiness levels, or however you want to assess the maturity of a technology, to get it to the point where a private entity can commercialize that technology. That's what we bring with Idaho National Laboratory. We've got these public-private ventures where the government is not just giving money to a vendor for that vendor to do their own research in their
Mhm.
own laboratory to de-risk their design. That is happening. I oversaw a number of those types of partnerships when I was at DOE. And at Idaho National Laboratory, we are actually in those active partnerships with industry to help de-risk their designs. But more than that, on what you just raised, I've got land at INL. I've got almost 7,000 of the smartest nuclear energy folks you can find in the world. And I've got unique facilities that can do experiments and handle nuclear materials and fuel and whatnot. So I can bring a vendor that can go to INL and say, hey, I want to build my pilot reactor there. I've got the design. I've got the hardware, coming out of the best manufacturers in the United States. But what I need is a regulated, nuclear regulated area, say at INL with the Department of
Mhm.
Energy regulatory oversight, where I can put this thing in the ground and make sure it all works as designed. And I want to run it and just make sure that I've done everything I need to do to show my investors that this is commercially viable and that I can now scale up in my factory and deploy it elsewhere in the US or around the world. That's the type of partnership we're seeing now, led by the Department of Energy and enacted at the Idaho National Laboratory.
From an IT leader's perspective, not every IT leader is like, I need my own like nuclear reactor. Is there, what like Is there a tipping point? Is there, kind of, or an inflection point in terms of like you're an organization that needs a data center doing this kind of work at this size, and you should be considering this, and then other folks like, no, the traditional methods of getting AI are going to be, sufficient for you. Is there a line to draw on like how do IT decision makers, think about this going forward?
Yeah, the in the conversations that I have, and this goes back to some foundational discussions that we were having in the Department of Energy headquarters. I'd say through 2023 and certainly into 2024. And again, noting ChatGPT, I don't mean to keep harping on that, but we were talking about load growth in the U.S. due to an electrified economy and reshoring of industrial processes. So we were looking at load growth, but I'm telling you, those load growth projections didn't shoot up until this idea that AI could be adopted widely around the world and really drive up load growth. So through 23 and 24, we started having conversations in the Department of Energy headquarters building with many of the AI developers, I'll say the hyperscalers primarily,
Hmm.
and the utilities, along with a number of nuclear vendors in many of those conversations. And what was clear to me is that there was value in, and I didn't come up with this idea, but it's been in my mind for my entire career, so I don't know who to attribute it to, but it's the idea of complicating the problem, right? Sometimes in a bilateral negotiation, you can end up in a stalemate because there's nothing left for either side to give, and you truly arrive at an impasse. There can be an opportunity when you complicate the problem by bringing in other entities that have something to give. And suddenly, when you're in a trilateral or some sort of a multilateral discussion, you find that trading off equities around the table ends up getting you to a favorable conclusion for everybody. That was my conclusion as we engaged in what I'll call kind of these three-party type discussions of utilities, AI developers, and nuclear developers. It seemed that there was something in it for everybody that I did not see exist when I was in the room for utilities and nuclear vendors, right? Going back to what we talked about as the stalemate. So for the IT leaders out there, I'd say, think about where you're headed. It could be your sustainable energy strategy. Nuclear fits into that because of its carbon-free footprint. It could just be to meet load growth projections in your customer base, right? So it could be solely based on economics. Whatever you're for, and I would submit to you for most, it probably is a combination of those and other equities. But when you look at your forecast over the next 10 years, understanding where nuclear is and where nuclear is headed can be very valuable to sitting down and having those discussions with utilities, nuclear vendors, other energy producers, because perhaps natural gas is your bridging solution. So you want to have, your favorite natural gas developer in there as well, so that you're putting together a holistic profile of what the next 10 years of your company is going to look like.
Looking at just to 2030, if small modular reactors succeed, what does the energy landscape look like for companies and IT leaders listening to this show? Will they notice a difference, I guess is my question.
I would expect by 2030, we've got our first commercial deployment of a small modular reactor.
Mhm.
And again, I'll throw micro reactors into that category. We'll have the first commercial deployment by 2030. I suspect it'll be even quicker than that. And there have been some wind in the sails from the current administration to go, to accelerate these planned deployments. So I have been saying 2030 for the first commercial deployment. I hope I'm proven wrong and someone beats that, and I bet that's going to happen. But what I think the AI data center industry is looking for is that commercial scalability. So while I think we're going to have a lot of great wins this decade and a commercial deployment by the end of this decade, what we really need to turn to is, what does this country need to get serious electrons on the grid as soon as possible? That's going to require scaling up the supply chain which is going to be a big part of this challenge we've got facing us. It's going to mean scaling up the fuel supply. Enriched uranium is not something that's necessarily easy to come by, and our plan is to stand up domestic capability for enriched uranium. That's going to take some time, and the Department of Energy is off to make that happen. And frankly, the workforce. If I kind of draw three pillars here, the third one is the workforce. This is a lot of construction that's going to go on around the country, both in the factories that are producing the small modular reactors, and then out on site. Even though you've got a smaller construction footprint than you've got for the large scale reactors, there is still construction that'll have to happen to support these. So from a construction trades standpoint, and all of those great American jobs that'll be needed to go scale up the nuclear industry, that's on my mind. How do we work with the trade schools, with community colleges to one, get folks excited about going to do the thing? There's a lot of great paying jobs at stake here. But two, to bulk up those programs to actually turn out those excited folks that are ready to go make this happen.
So that's the future. Small modular reactions, factory built, potentially online by the end of this decade. But here's the thing. Most IT leaders can't wait for 2030. Their crisis is happening right now. Racks that used to draw 20 kilowatts are pushing 200. And cooling systems built for last decade servers can't handle the heat from tomorrow's GPUs. So now we're turning to someone who helps organizations solve these immediate challenges. Ryan Hotchkin is Senior Director of SHI's Advanced Solutions Group. He works across the entire infrastructure stack: servers, storage, chip makers, power and cooling, advising customers on how to actually build and run AI-ready data centers in a world where the physics are working against them. Ryan, welcome to the show.
Yeah, thanks so much for having me.
For our listeners who may not know you, tell us your name, your role at SHI, and what you oversee.
Yeah, so my name is Ryan Hotchkin. I'm the Senior Director of our Data Center Partners in the ASG group at SHI. So I oversee all of the data center partners that are in the server, storage, power, cooling, or chip manufacturer markets. So some companies that our customers may be familiar with would be Dell's, Lenovo's, NVIDIA's, Vertiv's, Schneider Electric, etc. All of those I have purview over at SHI.
What brought you into this space and what's kept you focused on it, and why is SHI focused on it?
Yeah, so when I first moved into partner management maybe 12, 15 years ago, I started with Red Hat. And so I was really focused on selling Linux, which is obviously operating in the data center. And then since then, I kind of took a meandering path working on cybersecurity, kind of in the firewall infrastructure outside the data center. But really, the best way I can explain it to you is with an analogy. So I just bought a brand new truck, and I bought a Ford F-150. So I'm texting my friend group, and I'm like, oh, hey guys, I bought a brand new truck. The first question that I got asked was, oh, is it the V6 or the V8? Like, the thing we gravitate towards is what's the engine, right? And the data center is the engine of IT. It's where the power comes from. It's where all the excitement comes from that makes everything else work. So that's what makes it, to me, really, really exciting. And then obviously with everything going on with AI, like, the sky's the limit in what we can do now. And it's only going to get more and more interesting.
Why did you want to add the right now perspective to this conversation? So Brian told us, like, here's what's coming. But you were like, hey, we got to talk about right now. Why is that?
Yeah, it's important to make the distinction for everyone listening that although the big picture items are going to take a couple of years to work out, right? Anytime we want to make changes to the US power grid, it's going to take some time to do that. But if you don't start today, you're not going to actually be able to do it. So for SHI, as we look at, helping customers navigate through these challenges, the real answer is if you're not thinking about it today, if you're not planning for 3 to 5 years from now, you're going to miss it. And you're not going to be able to actually execute in 3 years if you don't start today. So that's why it's really, really important to understand where you are, where you're looking to go, and what your options are in the meantime.
You just brought up a really interesting perspective on the power grid. Like here in New Jersey, our hospitals, some of them are 200 years old, right? And I always say when you walk down a long hall in a hospital, it changes direction 2 or 3 times for all the different times that they added on to that, as population grows and technology and things like that. Like I hadn't thought about like the changing the power grid, enhancing it. It's got to be the same thing. You cannot shut it down. It's got to be done on the fly. So that's pretty interesting.
Another thing to just be thinking of, because when we first started dealing with this, you have to think about in your data center what the weight limit the floor is rated at. And in the past, that wasn't really a concern. But now that these racks are so heavy, it's like, oh no, it has to be basically a cement slab that you're putting stuff on top of, which that didn't used to be the case. And like, that's not something a traditional person in IT ever would be thinking about other than when you have to in the situation like this. So there's a lot of those nuances that you just need to be aware of and be thinking of, or you're not going to be able to make those key changes.
For listeners who haven't been tracking the power demands inside data centers, walk us through the numbers. What kind of power did a typical rack require a few years ago? What is the current generation of AI hardware demand? And what's the gap and where is this heading?
Yeah, it's a great question. And honestly, I lean nerdy. So that's how my brain works, where it's really that math mindset. But if you think about a rack in a traditional data center that may be running certain workloads, it was probably in the range of 20 to 40 from a kilowatt perspective per rack. If you're looking at NVIDIA's H200s, which is, I would say maybe even today that's kind of old technology, but that's the thing that most companies are really utilizing if they've adopted AI. They're about 60 kilowatts per rack. So it's anywhere between 1.5 to 3 times the power. And then if you look at NVIDIA's GB200s, the NVL72s, now we're talking at about 120 kilowatts per rack. So realistically, what NVIDIA is doing is every year they're doubling the power per rack based on the GPUs they're able to invent in order to drive kind of all the AI outcomes that we're looking at. So today, right, if we were 20 kilowatts per rack and now we're 120, and it's only going to exponentially increase. And obviously, that brings with it a whole lot of other challenges because we know we need the engine, so to speak, in order to drive the AI outcomes we're looking for. But now we also need to understand with that power, right? Power creates heat. Heat needs to be cooled down or else you'll potentially melt the rack. That's now something we need to think about. Additionally, as you scale that from 1 rack to 100 racks, now you're talking about, well, how much power comes into the building? Do I even have enough to meet those needs, right? And then, by the way, to the previous comment, like the increase in liquid cooling increases the weight of the rack. So there's some other considerations there as well. So it really is kind of this math problem where you need to understand, okay, what are my AI outcomes? What is the power requirements to meet those AI outcomes? And then what is the cooling requirement to meet that power requirement? And how do I make all that work in the facility? And understanding that you have to do space is always going to be a concern, but also make sure you have the infrastructure to support both the liquid cooling, but also the power consumption.
Brian told us that AI is becoming the catalyst for nuclear investment. From your vantage point, how is AI accelerating power consumption inside enterprise environments?
Yeah, it's exactly what we were previously talking about, right? So AI is going to change the way all of us do business. It's going to make us more effective, more efficient, more scalable, and able to do more with less, right? But the requirement in order to execute on that is you have to be running these high-end GPUs. And as you do that, there's a subsequent increase in power consumption. So it is actively driving this demand, and it will continue to do so as long as we continue to adopt AI. And if you pay attention to the industry, that is the direction we're going. This is the new normal that we're heading down into. And it's the forcing function, right? So AI is forcing us to now get more efficient. But there's also a couple of steps you can take in between now and then, which is also worth educating our customers on to understand this is where I'm going. These are the impacts on my business. I know I need to do it, but let's figure out how to get there together.
So in terms of the stakes for our listener, like what does it actually look like when they get it wrong? Is this and what's how are they evaluating, what success looks like in this? I mean, it sounds like a really big deal to get this right.
Yes. So as I alluded to earlier, this is really important, right? The companies who do this well are going to take massive market share, and the companies who don't are going to start to fade away. So this is a critical piece and time for all the people listening. Now, the next part about that is, well, okay, if I recognize how important this is, and it's kind of a career-defining moment, let's make sure I do it right. So, okay, what does doing it right look like versus doing it wrong? Doing it
Mm.
right looks like having a well thought out plan that is probably a 3 to 5 year plan filled with short wins to allow you to generate the ROI, but also make the right key critical investments in AI and in these, initiatives in order to set your company up for success. So on the flip side, what does bad look like, right? That's when and by the way, I've been in IT for a long time. I know you have as well. We've all
Yep.
talked to customers who bought a brand new cool appliance like, hey, this new technology came out. I just bought it. It cost me
Mm.
$300,000 and now it's sitting on a shelf, right?
Mm.
And generally speaking, the reason they did that is because they didn't have an IT manager who was able to install it and set it up because it was a new technology they weren't familiar with, right? Well, if you think about that, that could happen today as well anytime we're evaluating AI technology. Even worse, let's say they're an expert, they know the technology, they go to try and install it. If they try to install it, but they don't have enough power in the building to turn it on, that's a huge problem. The other thing that I don't think a lot of people realize is power in a rack isn't stable. It kind of goes up and then down and up and down. And when they tell you the power, so when I say like a regular a rack is 20 to 40 kilowatts, it could spike up to 42. So if you're at max capacity of power and your GPU spike going over the capacity of power you have, it could bring the whole rack down, right? So there are some real situations that could cause problems for customers if they're not aware of this as they try to implement it. Now, the last thing I'll say to kind of, round this out, the investment in AI, the actual dollars behind it are so much higher than previous investments we've made, right? We're talking about $1 million, $10 million, $100 million deals here. If I'm an IT director and I go buy a $10 million AI solution and I wrap power and cooling around it to kind of state of the art in my data center, and oh, by the way, it's probably 10 million and then 5 million and 5 million the next 2 years. If I do that and I don't get the ROI back from it and I don't future-proof my organization, I'm going to get fired. That's just the nature of the beast of the job that we're in right now. These are so expensive and it is potentially a career-limiting decision. And it's something that we need to make sure we do the right thing at the right time and be very confident in that.
And we're beginning to touch on this. I mean, there's right now, there's pressure from the C-suite, both business and IT, and like, hey, what is our AI story? Especially for publicly traded customers who have boards, who have shareholders. Like, we have to have a story. So is it just a story? Is it something that we've rolled out? Is it something that we're planning? And you said something to our producers that was really interesting. You said you think that the customers who are in the best position right now are the ones who aren't deploying AI yet, but they will in 3 years. So their story might not be so great right now, but why do you think that the customers who haven't deployed AI now they actually have an advantage?
Yeah, of course. So if you think about this, right, AI is the Wild West. We're all kind of expanding into a lot of different areas. We're trying new things we've never done before. Some are working, some are not. And in a situation like that, one of the smartest things you can do, if you have the flexibility to do so, is to pay attention and watch what's going on and see who's winning and then model your behavior after them. Now, the other part is, if I'm trying to roll out AI today at mass, it's going to be it's going to be very difficult to get all your ducks in a row to do it properly. You're going to have to make a couple of trade-offs here and there because you're not going to be able to get the power set up correctly. You're not going to be able to get the liquid cooling set up correctly. Or imagine you need to build a new data center. Like, what does that look like? That's a 3 to 5 year build in the future to get that set up correctly, right? So recognizing that, if that's our aim, and if we have 3 years to get there, you're in a really good position. But I will caution you to say, you have to start planning this today, and you have to build the plan and begin moving it forward today. It's not oh yeah, we'll worry about this in 2 years, and then we'll be able to look at what everybody else did and adopt that. It's no, you need to start today, but recognize that you can look at the industry around you, and that's going to give you the opportunity to learn from everybody else's mistakes as they continue on their journey.
So speaking about planning today, when should customers be talking to SHI and what happens when they do?
They should talk to us right now. I would encourage anyone who found any of this conversation interesting to call their SHI rep. Now, I've been in the IT industry in the data center for 15 years, and the problems that are coming up today are problems I've never seen before, and we're all having to learn a lot of new skills that we've never learned before. This is a really critical moment to have a consultative partner you can trust that can bring the right experts to you to walk you through this process. There's a whole lot of gotchas in adopting a lot of this technology, and SHI has that expertise. We've done it ourselves. We've proven it out. This is the time to talk to a trusted partner about all of that and really start planning out what this could look like for you and to imagine what that future could be and then start taking those first few steps forward. That's what we're here for. That's what we do really, really well.
Yep, and we'll be here. So thanks to Brian Smith of Idaho National Laboratory and Ryan Hotchkin of SHI for taking us inside this critical challenge. And thank you for listening to Innovation Heroes, an SHI podcast. I'm Ed McNamara. Until next time, keep pushing the boundaries of what's possible and keep innovating.